So today we continue taking a look at equations of lines. Today our goal is I can find the equations of a line if I know another line that is parallel or perpendicular to it. So we're going to be talking about parallel lines. And that's the symbol we use as a short form for parallel. Kind of looks like a tall 11. And the short form for perpendicular is like an upside down T symbol. Okay, so just something to keep in mind when we're discussing parallel and perpendicular lines. So when we look at parallel and perpendicular lines, their slopes are certainly related to each other. So if I'm looking at this first graph, and I'll call that line 1 and that line 2. Okay, remember that slope is equal to rise over run. So if I'm going to find the slope of line 1, so maybe I'll go from that point to that point. So working from left to right, this has a rise of 2 and a run of 3. So that's the slope of the first line. And if I do the slope of line 2, so I'll use this point. And remember, I can use any 2 points that are on the line. So let's try those two. So this one has, again, working from left to right. So the rise from the point on the left to the point on the right is 4. And the run is 1, 2, 3, 4, 5, 6. So it's 4 over 6. And I should always put these fractions in lowest terms. So it has a slope of 2/3 as well. So our conclusion here is that parallel lines have the same slope. And you may have already known that, but it's worthwhile to take a look at the slopes of the lines and see if that is in fact true. So now we've got a couple of lines on the second graph, and these lines are perpendicular to each other. They meet at a right angle there. So let's do the same thing here. I'm going to call that 1 and that 2. Let's start by finding the slope of line 1. So if I'm going to find the slope of line 1, I can go from that point to that point. So it's got a rise of 3 and a run of 2. And now I'll do the slope of line 2. And I can use this point, and I might as well use that point where they intersect. So this one has a rise, because it's going down, that's going to be a rise of -2 and a run of 3. So -2 over 3. So perpendicular lines have slopes that are, and if we look at the two slopes, you can see that they're similar, but they're not the same like they are with parallel lines. So these two slopes are actually flipped, the numbers have flipped, and one's positive, one's negative. So the mathematical description of that is we say that they are negative reciprocals. So the negative is the difference in the signs, and the reciprocal means that it's flipped. So you can also describe this as the slopes are flipped and signs change. Okay, so that's the relationship between parallel and perpendicular, and we're going to use those relationships to help answer some of these questions here. So in example 1 here, it says give the equation of a line parallel to this line. So we know that the slope of this line is 5. So I just need to write the equation of a line that has a slope of 5. So I can simply write y equals 5x, and then I can add or subtract any number I want on the end. So there's obviously an infinite number of possibilities here for our equation that's parallel to that, but y equals 5x plus 7 is one of those. Now we want to give the equation of a line that is perpendicular to y equals negative 2x plus 6. So if the slope of this equation is negative 2, we need to know what a perpendicular slope would be. So keeping in mind that negative 2 is like negative 2 over 1, and don't forget that perpendicular slopes have negative reciprocals. So that means we have to flip the 2 over 1 to 1 over 2, and we change it from negative to a positive 1/2. So that's the slope that we need to use here. So now I can write the equation. Y equals 1/2 x minus 13. So what I use as the y-intercept in these cases doesn't matter, as long as the slope has the relationship we're looking for. So example 3, give the equation of a line perpendicular to this one. So a couple things we can do. This equation is more difficult to get the slope from. So one thing we could do is change to y equals mx plus b form. So if we can change it to slope y-intercept form, like it was in examples 1 and 2, it's easy to pick out what the slope is. So if we do that work here, so I'm going to write down my 5x minus 6y plus 3 equals 0. So remember, when I'm changing it from standard form to slope y-intercept form, I need to move things away from the y. And then when I reach this point, I need to divide each thing by that negative 6. So what I end up with here then is y equals, and I have negative 5 divided by negative 6. Because it's a negative divided by a positive, I can just write a positive. And I can't simplify 5 over 6 at all. And I've got negative 3 divided by negative 6, so that's going to be a positive. But 3 over 6 I can write as 1/2. All right? Now that I have it in this form, then I can use my slope is 5 over 6, and I want something that's perpendicular. So the perpendicular slope is equal to negative 6 over 5. So if I'm going to write an equation with that as my slope, I can write negative 6 over 5x plus 2. So that's a possible answer for that one. Now I do want to show you a little bit of a shortcut to get the slope and the y-intercept from an equation that's in standard form. So we know that standard form is ax plus by plus c equals 0. We can actually calculate the slope by using the equation minus a over b. So if we do that for this equation, a is 5, so that's going to be minus 5, over b is minus 6. So I can get the slope there, or I can do it the way I did here. Okay? This is probably a little bit more work than what I just did here. So that's always an option for you when you need to get the slope from that standard form. All right, so keep that in mind. So example 4 here, we want to give the equation of a line parallel to that line that passes through 5, negative 2. So let's start with the slope, and let's use that shortcut. So the slope is minus a over b. We need to know the slope of this line to start with. So minus A over B, that means that the slope of that line is 7 over 3. So the slope that we're going to use for our equation, because it's parallel, we're going to use that same slope. So our slope that we're going to use is 7 over 3. And then we have the point 5, negative 2. So this is back to like what we worked on in our last topic. And remember how we talked about the fact that when we have a fraction slope, it's probably going to be a little bit easier to solve if we use this form for the equation of the line. So I've got my m. Keep in mind that this is going to be my x1 and my y1 when I substitute them in down below. So y subtract negative 2 is going to actually become y plus 2. My slope is 7/3. And then I'm going to get x minus 5 in my bracket. And this is the point where we want to get rid of the fraction. We move the 3 over to the other side, and it's going to change to multiply. And then we can expand. Each bracket will use the distributive property, so we're going to get 3y plus 6 equals 7x minus 35. And then we'll move everything over to one side and make it equal to 0. So we're going to end up with 7x minus 3y minus 41 as the equation of a line that's parallel to this line, and it goes through that point. All right, last example here. So give the equation. You know what? We're going to leave this. We're going to do this as a warm-up tomorrow. I think this is a good pattern for us. That'll give us an opportunity to discuss things and do one practice question together before you start the practice questions. Okay? So we'll see you tomorrow.